All right, Mr. Ahmed here for 5.2. 5.2, our goal is still to solve systems of equations. We are just going to go over a new method. So the only method that we've gone over thus far is by graphing. Graphing is a very good visual representation of all the solutions for both lines, and then where they intersect, that's where both of them are true. However, if those lines don't intersect at an exact point, or if the numbers are big and it goes off of our graph, I mean, there's just numerous reasons why the graphing method has its limitations. All the problems we kind of set you up with for the graphing ones worked out nice, but not every single problem in the world is going to be a nice number that fits on a 10 by 10 graph. So in order for us to solve these, we can also use the substitution method. All right, and when we use substitution, one of the equations needs to say x equals or y equals. Doesn't matter, okay? We just need to get x equals or y equals. And it doesn't matter what it equals. We're gonna circle that equation, okay? Sometimes one of these variables is already gonna be isolated. If it's not, we need to be strategic in picking which one we want to solve for. We don't want to end up with fractions. All right, we want an easy step in order to isolate a variable. It doesn't matter what variable we isolate. It could be x, could be y. We just get to pick, but we're going to be a little strategic. After that, we're going to substitute that circled equation into the other equation, and then we are going to solve, because that will make it so there's only one variable. Then we're going to plug that answer back in to find the other variable. So when I look at these two equations for the first example, the top one already has x equals. X is isolated, so this is the one that I am going to use. I am going to take what x is equal to, which is negative 2y plus 2, and I am going to substitute that into the other equation for x, and I have to use parentheses. So when I substitute that in, I would have 3, and then my parentheses. What is x equal to? X is negative 2y plus 2. So I substituted that in for x. I still have my minus 4y, and then equals 26. So notice this equation that we manipulated no longer has an x and a y. It only has y's in it, so we will be able to solve it. So now we're just going to follow our steps to solve. The first thing we are going to do is distribute. So I'm going to distribute my 3. I'm just going to use one color. 3 times negative 2 is negative 6y. 3 times positive 2 is plus 6 minus 4y equals 26. Now we can combine our like terms. Negative 4 and negative 6y, those are like terms, so those get added together. That turns into negative 10y. They're on the same side. Plus 6 equals 26. Subtract 6. Negative 10y equals 20. And when we divide, y is equal to negative 2. We divide by negative 10. Divide negative 10. So we found y. Y is negative 2. That's one of the solutions. We still need to find x. Typically, I'll substitute that into the equation that was circled because x is already isolated. So we're going to substitute that in there. So we have x equals negative 2 times y. Y is negative 2. We substituted it in. I'm going to rewrite the equation just so everyone sees it. Negative 2y. We're putting it in there. Plus 2. That's the equation that we're substituting it in for. Then we also have a plus 2 at the end. So negative 2 times negative 2 is x equals 4 plus 2. 4 plus 2 is 6. We found our two solutions, 6 and negative 2 as an ordered pair. X comes first. There it is. Now you could substitute these back in to check your work as well. All right, I'm going to do it on this one. I'm not going to do it on every one. So when I substitute my answers back in to the top equation, we'll do that in red, we'd have 6 equals negative 2 times y. Y is negative 2 plus 2. Does that work? Negative 2 times 2 is 4 plus 2. That's 6. That one works. Other one, 3 times x. So that's 3 times 6 minus 4 times y. That's negative 2 equals 26. Going to simplify this one a little further. 18. We have a negative 4 times a negative 2 changes to a positive 8. equals 26, and that is correct. 18 plus 8 is 26, so it worked for both. We got it right. Like I said, I'm not going to check every single one. Okay, on to our next example. So this one does not have a variable isolated already. Okay, really I have options though. I mean, I could solve for x on the top equation because I just have to subtract 2y. I could solve for x or y on the bottom equation. Okay, the choice is yours. There's numerous options of how we could proceed from here. I'm going to take the top equation and solve for x. So x plus 2y equals 10. I need to subtract 2y from both sides. And I get x to equal 10 minus 2y. There's my circled equation. I solved for x. We now need to substitute that into the other equation right where the x is. Put in a set of parentheses. Okay. So x is 10 minus 2y. 10 minus 2y has to go in for x. So when I rewrite, I would have, I'll write it down here, 10 minus 2y in parentheses plus y equals 6. Okay, there's nothing to distribute on this set of parentheses, so I just need to combine like terms. 2y, or negative 2y plus y is a negative y, so I have 10 minus y equals 6. Subtract our 10, and we get negative y equals negative 4. We still have to divide by negative 1, and y is equal to positive 4. So we found our first value. Like I said, I always plug it back into the equation that I had circled. So y gets plugged in here, plug it in. X equals 10 minus 2 times y. Y is 4. So that's 10 minus 8 equals x. X is equal to 2. So the ordered pair, x comes first, 2, 4. We got it. Oh, didn't have that shown. 2, 4 for the ordered pair, x, y. If it's an A and or B, A would come first. The smallest letter in the alphabet comes first. So why would I use substitution instead of graphing? I'm not going to write all this down, but I mean, why would I use this? It's more accurate. I don't have to be super precise. If I get a fraction for an answer, it'll show up correctly rather than just trying to guess where it intersected on the graph. And sometimes it actually is quicker than graphing as well. Or I might not have graph paper, okay? So for the next few tries, my recommendation is you take a pause here, give these two a shot. If you get stuck, unpause it, and then see where you're at, all right? Okay, hopefully you had some success. So when I look at the first one, y is already isolated, so I'm circling that. I'm using that equation because y is equal to something. Needs to get substituted into the other equation for y. Make sure we use parentheses. So I have 3x minus 8. Now my parentheses come in for the y. Parentheses. What's y equal to? Y is 5x minus 3. That goes in. And then we have equals 24. So we substituted in what y is equal to in for y. Now we got to solve it. So we're going to have to distribute. 3x stays. Negative 8 times 5 is negative 40x. Negative times a negative is a positive 24. Equals 24. Okay. 3x minus 40 is negative 37x plus 24 equals 24. Subtract our 24s. Negative 37x equals 0. That is still there. And now we're dividing by negative 37. Divide negative 37. And that does work. This is not undefined. 0's on top. So x is equal to 0. We found x. Now substitute that into the equation that was circled, which is y equals 5x minus 3. 0's getting put in. Y equals 5 times 0 minus 3. 5 times 0 is 0. And 0 minus 3 is negative 3. So y is equal to negative 3. We found it. The ordered pair is 0, negative 3. Okay. Last example. All right, now this one is a little bit tough. Not gonna lie, all right? I'm gonna have to make a couple steps when I isolate a variable. And I think when I look at this bottom one, 7, 8, 5, those are a lot of odd numbers. I don't see me getting away without getting fractions on that. On the top one, I have all even numbers, however, and I think I can isolate x without ending up with fractions. So I'm gonna take the top equation, negative 2x plus 6y equals 6. I'm gonna solve for x. All right, you could try and solve for y, but that's not gonna be as easy. All right, that is an option though. I'm gonna solve for x. So I gotta subtract 6y from both sides. Keep in mind, only combine like terms. Negative 2x is equal to 6 minus 6y. Divide both sides by negative 2. When you divide both sides, you have to divide both terms. So x is equal to negative 3. Negative divided by negative is a positive. That's going to be a tricky spot. Negative divided by negative is a positive, 3y. So now we have x solved for. Now, a couple key things. Which equation we use? We use the top one. So I can't substitute it into the top one. I need to substitute it into the bottom one. Okay, so I'll rewrite it. Negative 7x, there's my parentheses, plus 8y equals negative 5. We're going to plug in what x is. Negative 7 parentheses. X is negative 3 plus 3y, close it, plus 8y equals negative 5. So we substituted it in. I should actually have written this in red, because that was the original equation. My orange got put in. All right, now distribute. Negative times a negative, positive 21 minus 21y plus 8y equals negative 5. Combine our like terms. Negative 21 and 8 would be negative 13y plus 21 equals negative 5. Subtract 21, cancels. Negative 13y equals negative 26. Divide. And y is equal to 2. So we found y. We still need to substitute that back into the circled equation to find x. X equals negative 3 plus 3 times y. Y is 2. Negative 3 plus 6 is equal to 3. We got it. So our ordered pair is 3, 2. So a little bit tougher there on that last one. That's it for today. Have a good one.